In this ACT video, we're going to review the basic elements of geometry. And if you recall from your geometry class, there are a lot of new words, a lot of new symbols, a lot of new definitions. So we're going to go over those introductory words from geometry. We're going to start with our most basic term, which is just a point. And you really can't define a point. We use in geometry a nice little dot to represent a point, and we may name it point A, and we use capital letters. More interesting than that, though, is the line. And when we draw a line, it can go off in any direction with arrowheads. And you need 2 points to define a line. So what if we name this point X? We'll name this point Y. Now those are not the only 2 points on the line, but we need 2 points to define it. Now for your symbols here, we could call this line XY. We could also call it line YX. So remember, you can flip-flop those letters. And then sometimes we just use a little cursive letter, lowercase. So then we might also call this line L. Okay? So there's some symbols there for line. Again, there's infinitely many points on the line. We need 2 to define it. All right. Also, a line segment. A line segment is just a piece of a line, and it has 2 distinct endpoints. It can also go off in any direction. Now, there are infinitely many points in there, but when we name a line segment, we name it with its endpoints. So we might name this segment PQ, or we can also name it QP. So we can flip-flop those letters, and that's the little symbol we put over the letters. Notice the difference between the symbol for line and the symbol for segment. And then we also have a ray. And a ray has a distinct endpoint, and it goes off in one direction forever and ever. Okay, almost looks like a hand on a clock. And we also need to find another point on there. We might name this ray, let's name it AB. And that A is what we call the end point. There's only one way to name a ray, and that is by the end point first. So this is AB, ray AB. You cannot flip-flop the letters. You can go back and forth with the letters when you name the line, and you can go back and forth with the letters when you name the segment. But for the ray, the first letter has to be the end point, and then that's your little symbol that goes above those letters. Now, some three-dimensional type things. They don't have to be three-dimensional, but we're going to use a 3D figure to look at them. A plane. Well, let's see. We can use this symbol, almost like a parallelogram type symbol, to represent a plane. And you need 3 non-collinear points to name a plane. Okay, and non-collinear means they're not in the same line. So let's just take this figure, for instance, and let's take, it looks like maybe a tissue box or something. That's a good example. Or the walls in the room. And we've got these 4 corners, so I only need 3 of those non-collinear points there to name that plane. So I might name it plane ABC. But I could also name it plane CDA. Any combination of those letters would work. It doesn't have to be the ABC. It's still naming the same plane. It's still naming this plane. That's the top of this box. I'm kind of shading it in with the green here. And as you can see, we have a top plane and a bottom plane, a front and a back, and a left and a right. So that's actually 1, 2, 3, 4, 5, 6 planes. Now sometimes we may use a capital letter. So let's use this example over here, if I can squeeze that in. Capital cursive letter, and in that case, this plane right here might just be plain capital cursive letter M. Now, parallel lines, we can use this three-dimensional figure to talk about parallel lines. We talked about parallel lines algebraically as having the same slope, but we know parallel lines don't intersect. And a couple of symbols we use for parallel lines, if we're just drawing the lines, we might draw these little symbols on there, maybe like little triangles. That's a good marking to show they're parallel. I may call this line L and this line P, and I could say that L is parallel to P. And so those two bars represent parallel lines. Okay? And so in this case, looking at my three-dimensional figure, AB here is parallel to CD. Perpendicular lines, they intersect to form right angles. Okay, right angles. And our symbol for perpendicular lines, let's draw some. This might be your line L, and this could be line N. And they intersect at right angles, so you'd probably see a little marking there of some sort. And we would say line L is perpendicular to line N. So this right here is your symbol for perpendicular. Now, skew lines are a little bit harder to describe. Parallel and perpendicular should be fairly common, but skew is a little bit different. And skew lines, we're going to use our three-dimensional figure here to describe skew lines. They're not parallel and they don't intersect because they're in two separate planes. Okay, so the best way to describe this is, let's get the highlighter out. This line right here, AB, and maybe this line right here in the front, which we should name that so I can tell you which one we're talking about. What if we name that EF? Okay. Parallel lines are neither parallel, skew lines are neither parallel nor perpendicular, but they'll never intersect because they're in two separate planes. Another example of some skew lines, let's go ahead and name this back here, EF. Let's name that G, and let's name this corner H. And I like to use the highlighter tool to kind of really show you what we're talking about here. Maybe this purple color will work. So maybe line CF, although it doesn't look purple now, does it? It looks blue on blue. CF is skew with this line back here, AD. They'll just never intersect because even though they're going opposite directions, they're in two separate planes. So those are skew lines. So this was just a brief review of some very basic elements of geometry along with their symbols.